In this video, we are going to look at two equations that are equations of conics, and we are going to see if we can determine what kind of conic it is and answer at least some questions about it. To do this, we're going to use the method of completing the square. So remember, whether it's a hyperbola, a parabola, or an ellipse, it's all about perfect squares. So what we will do is we're going to group together all of the x terms and all of the y terms and use our skills at completing the square to go from there. So let's start with the first example here. So I'm going to go ahead and highlight. So here are my x terms, 4x squared and minus 24x. So I'm going to group them together. And then I have 25y squared plus 250y, and those are my y terms. 561 is my constant. So you can either choose to leave it on the left or move it to the right. I'm actually going to go ahead and move it to the right myself. So I'm going to rewrite this equation. I have 4x squared minus 24x plus 25y squared plus 250y is equal to negative 561. And what I'm going to do now is, using my skills at completing the square, I'm going to factor out the leading coefficients, complete squares, and neutralize just like I've done before. So check it out. I'm going to rewrite the equation again. So, like so, I'm factoring out the 4. And I'm going to leave myself some space here. So I have space to complete the square. For the y piece, I'm factoring out the 25. Again, leaving myself some space. And even though I didn't have to leave it, I have a little bit of space here on the end with the intention of using it to neutralize what I do here and here to complete the square. All right, so we're completing the square experts. We know that to complete the square, we're going to take the middle coefficient divided by 2 and square. So x squared minus 6x means we add 9. And same thing here. We're going to take that 10 divided by 2 and square. 10 divided by 2 is 5. Square that, we add 25. And we know that we cannot just go around adding things without neutralizing what we just did. And remember, again, this is not a function, this is just an equation. So we added 4 times 9, which is 36 to the left here. And we added 25 times 25, which is 625 there. So if we are adding those two things to the left-hand side, we also have to add them to the right-hand side. So I'm going to go ahead and actually write plus 4 times 9 plus 25 times 25, just so that it's really clear where those numbers are coming from. Okay, so rewriting, I have now 4 times x minus 3 quantity squared plus 25 times y plus 5 quantity squared is equal to, and then here we have negative 561 plus 36 plus 625. Okay, so I want you to notice that 36 plus 625, that is 661. So when I add that to negative 561, I get 100. So let's rewrite one more time. There we are. And then finally, for the finishing touch, I think at this point, we are all in a place where we can see, oh, this is an ellipse. I'm going to go ahead and I'm going to divide both sides by 100 to put it into that standard form that I'm used to seeing the equation of an ellipse. And what I see is x minus 3 squared is over 25 plus y plus 5 squared over 4 is equal to 1. So from here, I'm not going to go through the whole process of identifying the vertices and the foci. I would like for you all to kind of do that piece on your own. But I do want to point out the larger denominator is underneath the x piece. So that tells us that the major axis is horizontal. And if we think back to the traditional equation of an ellipse centered at the origin, we see that x has been replaced with x minus 3, so that's a shift to the right. And y has been replaced with y plus 5, so that's a shift down. So we'll say here, center is the origin, shifted 3 right, and 5 down. And 3 right and 5 down is 3, negative 5. So you can see that your major axis is horizontal. You can look at 25 to see the length of your major axis, but I'll let you kind of figure it out for yourself. And you also see that by noticing that x has been replaced with x minus 3 and y has been replaced with y plus 5, you can see where the center has been shifted to. So that is an example of a conic section that ends up being a shifted ellipse. Now let's look at this example. So in this example, you'll notice maybe straight away that there's no y squared term. While I'm not necessarily in the business of rules of thumb, I think it is useful to notice that the only conic that doesn't have both x squared and y squared in its equation is the parabola. So as soon as you see that there is no y squared term, you know that this is going to be a parabola, and moreover, that it's going to be a parabola that opens up or down. It's a good thing to notice, it's a good thing to be on the lookout for, but nonetheless, let's see what happens. It's mostly for sure that it's going to be parabola that opens up or down, but there's still a little bit to be seen. So let's go. I'm going to do exactly the same thing that I did in the previous problem, but once, because I don't have any perfect squares on y to complete. Okay, so what I'm going to do straight away is I'm actually going to, since I see that there is no y squared term, I'm going to take my y term and I'm going to move it to the other side. So that gets me x squared plus 6x plus 9 is equal to negative 12y. Oh, well, this is a perfect square, right? So I don't even need to go through the process of completing the square. This is already x plus 3 quantity squared is equal to negative 12y. So what this tells me is that this is a parabola. The fact that the negative 12, the fact that that's negative is telling me that it's going to open down. And what you can see is, kind of like in the previous example, we said x was replaced with x minus 3 and y was replaced with y plus 5. Well, x was replaced with x plus 3, so that's going to be a shift to the left, but y was left alone. So what that means is that you have a horizontal shift, but your the vertical coordinate of your vertex was not changed. So what we'll say here is parabola opens vertically. And in fact, we can even go further. We can say that it opens down because of this negative. And then also we can say that the vertex is the origin shifted left 3 units, and that's it. So in other words, the origin is the point -3, 0. So from there, again, it's a conic, right? And it's a parabola. And that tells us that all of the things that we said about the focus and the directrix of the parabola, all of that still holds true in this case, except that in this case, the vertex is not the origin, the vertex is the point -3, 0. So just like before, I'll let you go from here to find the directrix and the focus of this parabola. And the last thing I will say in this video is, if you complete the square, and for example, the way that we did here, you don't end up with a positive number here that you can, play with and continue on with. What that tells you is that your conic looked like something, but in fact, it was a degenerate that. So let's just, for the sake of argument, just kind of to wrap this up, let's say that instead of the first example, we had the same thing. So 4x squared plus 25y squared minus 24x plus 250y. But instead of plus 561, let's say that it was plus 789. Okay? Well, we would have done the exact same thing that we did here. So we would have moved the constant to the other side. We would have completed the square. And then we would have gone to neutralize there. Except that instead of -561, we would have had -789. So that when we added 36 and 625 to neutralize, we would have ended up with a negative number there. So this is an example of something we call a degenerate ellipse. And that's part of why I said that we thought that this was going to be a parabola because there was no y squared term. But until you really see it through, and here fortunately that process was really quick, until you see it through, you really can't be sure that it's actually a parabola, that it's not something that maybe deceptively looked like a parabola at first, but was actually a degenerate parabola. So be on the lookout for degenerate conics. You will come across them fairly rarely, but you will see them. And this really is the end of this video.